Alright, so let's get started with a little C++. Library string type. A string is a variable length sequence of characters. The use of string type, to use the string type, we must include the string header. Because it is part of the library, string is defined in the std namespace. Okay. This section describes the most common string operations. This section will cover additional operations. Okay. In addition to specifying the operations that library types provide, the standard also imposes efficiency requirements on the implementers. As a result, library types are efficient enough for general use. Okay. Defining and initializing strings. Each class defines, okay, this is default initialization, copy initialization, okay, from a string literal, and then with a header. Okay, each class defines how objects of its types can be initialized. A class may define many different ways to initialize objects of its types. Each way must be distinguished from the others either by number of initializers that we supply or by the type of these initializers. Okay. So these are some of the ways to initialize. We can default initialize a string, which creates an empty string. That is a string with no characters. When we supply a string literal, okay, the characters the characters from that literal up to but not including the null character at the end are copied into the newly created string. Okay, and when we supply a count and a character, the string contains that many copies of the current character. So there are 10 C's. Direct and copy forms of initialization. We saw C++ have several different forms of initialization using strings. Page 43. Let's try 50, 2.2.1. Right. Okay. Can we get back? What was the 288? Nope. 200. Yeah. Okay. Let's go ahead. Okay, there we are. Okay, so we're 113. Okay, right. So let me see what are the different types of 2.2.1, right? So I guess it will be around 70. 2.2.1. Okay, we have 2.2.1 variable, page 43. Okay. List initializer. Okay, there are initializers, different kinds of initializers, right? List initialization, default initialization. That's all, right? That is all. So we saw that C++ has several different forms of initialization. Using strings, we can start to understand how these forms differ from one another. When we initialize a variable using equal to, we are asking the compiler to copy initialize the object by copying the initializer on the right hand side into the object being created. Otherwise, when we omit the equal to, we use direct initialization. Okay. When we have a single initializer, okay, so this is direct initialization and this is direct initialization of S7. Okay. So when we have a single initializer, we can use either the direct or copy forms of initialization. When we initialize a variable from more than one value, such initialization of S4 and above, we must use direct form of initialization. Okay, this S4. We have more than one, right? Okay. When we want to use several values, we can indirectly use the copy. Okay, when we want to use several values, we can indirectly use the copy form of initialization by explicitly creating a temporary object to copy. Okay, so this is temporary object. Thus, initializer of S8 string 10cc creates a string of the given size and character value, then copies that value into S8. Okay, but why didn't we just go ahead and did S8 with that? Okay. Although the code used to okay, so this is copy initialization, direct initialization, again copy, right? Copy initialization. Okay, S2 is a copy of S1. This is also copy initialization or direct initialization. Okay, so this is direct initialization, but S2 is equivalent to S2 of S1. S2 is a copy of S1. S3 is a copy of the string literal, not including the null, and equivalent to S3 value. S3, okay. S1 occupies the number of characters of C. Right. Although the code used to initialize S8 is legal, it is less readable and offers no compensating advantage over the way we initialized S7. Right. Exactly. So these are ways to initialize the string. We have operations on the string. I think I should have string intro. Let's open it up. Yeah, okay, we initialized like data type. This called if I copying the value, right? This is direct initialization, and this is direct initialization with the you can also copy values. Okay, and this great. Okay, so operations on strings. Along with defining how objects are created and initialized, a class also defines the operations that objects of the class type can perform, right? That's true. Okay, a class can define operations that are called by name, such as ISBN function for sales item class. A class can also define what various operator symbols, such as yeah or mean when applied to objects of the class type, the common string. Okay. Then reading and writing strings. As we saw in chapter 1, we use the IOStream library to read and write values of built-in types such as int, double, and so on. We use the same IO operators to read and write strings. Okay. For this code. Okay. Ta-da, ta-da, ta-da. Empty string, read string, and then we go like that. So we can use the same operators to read and write strings as well. Okay, read and string, output string operation. Write S onto output stream OS. Read white space, separated string to S. Then reads a line of input from IS into S. Okay, input stream. Okay, S is empty. Returns true if S is empty, otherwise returns false. S returns the number of characters in S. Returns the reference to char at position n in S. Position starts at 0. And this returns a string that is concatenation. Replaces. Okay, strings are equal if they contain, and comparison are case sensitive and use dictionary ordering. Okay. So this program begins by defining an empty string named S. There. The next line reads a standard input storing what is read in S. The string input operator reads and discards any leading white spaces, example spaces, newlines, tabs. Okay. It then reads character until the next white space character is encountered. Alright. So if okay. So if the input is hello world, note the leading trailing spaces, then the output will be hello with no extra spaces, right? Okay, like the input and the output operations on the built-in types, the string operators returns their left-hand operand as a result. Thus we can chain together multiple reads or writes. Okay, great. If we give this version of we get hello world, right? Okay, reading an unknown number of strings. Okay, we wrote a program that read an unknown number of int values. We can write a similar program that reads strings instead. Okay, while saying word and then we print. Okay, so in this program we read into a string, not an int. Then otherwise the while condition executes similarly to the one in a previous program. Hmm. Then we have the condition. The condition tests the stream after the read completes. If the stream is valid, it hasn't hit the end of while or encountered an invalid input, then the body of the while is executed. The body prints the value we read on the standard output. Once we hit end of while or invalid input, we fall out of the while. Okay, using getLine to read an entire line. I think I should have used getLine string operations. Let's open up operations 1 while, and okay, I did use getLine. Okay. Sometimes we do not want to ignore the white spaces in our input. In such cases, we can use the getLine function instead of the operator. The getLine function takes an input stream and a string. This function reads the given stream up to and including the first new line and stores what it read, not including the new line in the string argument. Okay, get it. After getLine sees a new line, even if it is in the first character in the input, it stops reading and returns. Okay. If the first character in the input is a new line, then the resulting string is empty string. Like the input operator, getLine returns its is stream. Wait. Okay. As a result, we can use getLine as a condition. We just input operator as a condition. Great. For example, we can rewrite the previous program and route one word per line to write a line at a time instead. So exactly what I did here. GetLine. So I can also, okay, I'm not doing that. Okay. Because line does not contain a new line, we must write our own. As usual, we use endl to end the current line and flush the buffer. Okay. The new line that causes getLine to return is discarded. The new line is not stored in the string, right? Then we have the string empty and size operations. The empty function does what one would expect. It returns a bool indicating whether the string is empty. Like the ISBN member of sales. Okay. Like the ISBN member of sales item, empty is a member function of string. To call this function, we use the dot operator to specify the object on which we want to run the empty function. We can revise our previous program to only print lines that are not empty. Okay. The condition uses the not operator, logical not. This operator returns the inverse of the bool value of its operand. In this case, the condition is true if the str is not empty. Right. Okay. The size member returns the length of a string, that is the number of characters in it. We can use size to print only lines longer than 80 characters. Okay. Then the string size type. Okay. It might be logical to expect the size returns an int, or thinking back, an unsigned instead. The size returns a string size underscore type value. This type requires a bit of explanation. The string class and most other library types defines several companion types. Okay. These companion types make it possible to use the library types in a machine independent manner. The type size underscore type is one of these companion types. To use the size underscore type defined by string, we use the scope operator to say the name of the size type as defined in the string class. Okay. So although we don't know the precise type of string type, we do know that it is an unsigned type, big enough to hold the size of any string. Okay. Any variable used to store the result from the string operation should be of type this. Okay. Admittedly, it can be tedious to type string. Then under the new standard, we can ask the compiler to provide the appropriate type by using the auto or decl type. Right. Okay. Because size returns an unsigned type, it is essential to remember that expressions that mix signed and unsigned data can have surprising results. Huh. For example, if n is an int that holds a negative value and then s size is less than int, will almost surely evaluate as true. It yields true because the negative value in n will convert to a large unsigned. Yes, obviously. You can avoid problems due to conversion between unsigned and int by not using ints in an expression that uses size. Uh, Comparing strings. Okay, so let me take a look at this, right? Empty size, not empty. Okay, then comparing strings. The string class defines several operators that compare strings. These operators work by comparing the characters of the string. The comparisons are case sensitive. Upper and lower case versions of the letter are different characters. Okay. The equality operator, equal to and not equal to, test whether two strings are equal or unequal respectively. Two strings are equal if they have the same length and contains the same character. The relation operator tests whether one string has less than or equal to or less than or equal to, greater than equal to another. These operators use the same strategy as a case sensitive dictionary. Okay. Then if two strings have different lengths and if every character in the shorter string is equal to the corresponding character of the longest string, then the shortest string is less than the longest string. Okay. And if every character in the short is equal to the then if any character at the corresponding position in the two strings differ, then the result of the string comparison is the result of comparing the first character at which the differ. Okay. As an example, we have hello. So this is smaller than, of course, this, right? Space. Use rule 1. We see that str is less than phrase, and this is greater, right? E. By applying 2, we see that slang is greater than str in phrase, right? Okay, assignment for strings. In general, the library types strive to make it easy to use a library type as it is. Okay. In general, the library types strive to make it as easy to use a library type as it is use a built-in type. To this end, most of the library types support assignment. In the case of strings, we can assign one string object to another, like this, to an empty string. Okay. Now it replaces string content both are empty strings. Adding two strings. Adding two strings yields a new string that is the concatenation of the left hand followed by its right hand operand. That is, when we use plus operators on string, the result is a new string whose characters are a copy of those in the left hand operand followed by those of the right hand operand. Right. The compound assignment character plus equal to appends the right hand operand to the left hand string. Oh. Appends the right hand operand to the left hand string. Right. Okay. Adding literals and strings. This line. Okay. Adding literals to strings. Okay, as we saw here, we can use one type where another type is expected if there is a conversion from the given type to the expected type. Okay, right. The string library let us convert both character literals and string literals to strings. Because we can use these literals where a string is expected. Okay, we can rewrite the previous program as follows. Okay, so S3 is comma, so we get hello world, no punctuation in S1 and S2, hello comma space world, and then a new line. So we get when we mix strings and strings or character literals, at least one operand to each plus must be of string type. This is important. Like this is valid, like this is not valid because there is no string operand. Right, then this is valid and this is not valid. Can't string add because these can't add string literals. String operand. Right. So mainly focus on these two. Like this and this. Okay, the initialization of S4 and S5 involve a single operation each, so it is easy to see whether the initialization is legal. The initialization of S6 may appear surprising, but it works in as much the same way when we chain together the input or output expression. Okay. The initialization groups S6. Okay, this initialization groups as, first we do this, the sub expression S1 plus returns the string which forms the left hand operand of the second operator of plus, right? Then we go, it's as if we have written this. Okay, so we group them first, then we have temp, then temp plus. On the other hand, the initialization of S7 is illegal, which is, we can see as those parentheses for the expression. Now it should be easy to see that the first sub expression adds two string literals. There is no way to do so, as the statement is in error. For historical reasons and for compatibility with C, string literals are not standard library strings. It is important to remember that these types differ when you use string literals and library strings. Okay. So we have this, write a program to read the standard input a line at a time, modify a program to read a word at a time. That's easy. Explain how white space characters are handled in the string input operator, and okay, okay, I can do that. Smaller font. So yeah, string ignores preceding. Okay. No. Then how do we write it? It's correct. Proceed. Proceed. Okay. Preceding white spaces, but ends the string when it encounters one after reading. Get line ignores white spaces. Let's see. Yep. Okay. Great. Then write a program to read the standard input a line at a time. Modify a program to read a word at a time. Maybe I can do this. Okay, 3.5.4. This is 3.2.2. So we go exercise 3.2.2. Exercise 3.5.4. What is this? Okay, so CD to exercises, then CD to exercise 3.2.2. Okay, let me create a new file. This is exercise 3.2, so I'll go 3.2.cpp. Let's open this. We go hash include IO stream Since we are using string, so we will also include string. Then we define the using stdcout, stdcn, and std string. And we go into main, return 0. Okay, so write a program to read the standard input a line at a time. Okay, so we can create a string line, empty string, then we'll go while get line cin line, then cout we go cout line, and then L. Okay, so clear, and G++ 3.2.cpp. Oh, sorry. And L. Then we go A. So I go Shane, right? Shane. Well. Okay. Then Shane. Well, Shane. Okay. Clear. And now I modify program to read a word at a time. So that is simple. We get rid of this. We go cin line. So it will only read a word at a time. So we have Shane will, Shane and will different, right? So yeah, clear. Then we have write a program to read two strings and report whether the strings are equal. If not, report which of the two is larger. Now change the program to report whether the string have the same length, and if not, report which is long. Okay, for equal. Okay, so this is 3.4, right? Okay, so we go 3.4 dot cpp. Let's open it up. We'll be using string. Okay, so we want to read into string, so we will create string first and second. Both are default initialized, hence are empty strings, and we will read in enter two strings cin first and cin second. Then we check if equality, right? So we go if write a program to read two strings and report whether the strings are equal. Okay, if first equal second, we go both strings are equal. Okay, else we put if first is greater than second, then we say cout first is greater and L, or we can say cout second is greater and right. So we go read a program report which is larger. Okay, this is larger and this is larger as in okay. So we can go G++ 3.4.cpp and then we go A and still cout and still a new line, enter a new string. Okay, both strings are equal. Okay, great. So since they were empty, I don't understand why cout entered two strings, why didn't okay, anyways, okay, now we are maybe I would have pressed. Okay, let's try Shane and then Shane. Both strings are equal. Say Shane and Shine. Shine will be greater. Shine is larger. Yeah. Okay, great. Then we write a program to read two strings. Okay, now change the program to report whether the strings have the same length, and if not, report which is longer. Okay, so now we change the program, so you can keep this. If first dot size equals second dot size, then we cout both strings have equal length. Else first dot size is greater than second dot size, then we go this first is simply this, first is longer or else second is longer. So let's try this. We have, let's say, ABC, both strings have equal length. AC and ABC is longer. We got ABCD and ABCD is longer. Clear. Okay, great. Okay, write a program to read strings from the standard input. Concatenate. White space are used to separate different strings while taking input from CN, but in case of getLine, it uses the new line character to determine the end of line. Okay, great. Preceding when it ends the string when return count is 1 after reading. Maybe this is better. Write a program to read strings from the standard input, concatenating what is read into one large string. Okay, print the concatenated string. Let's change the program to separate adjacent input strings by a oh, okay, that's great. So I can go 3.5.cpp. Let's open that. It's just I like to group these together. We'll go string, large string. Then we'll go and and string temporary. So we'll go while you want to concatenate to read strings from the standard input, concatenating what is read into one large string. Okay. Cin with temp, then we large string plus equal to temp. Then we simply print out the large string. Okay, there we go. Then we have G++ 3.5.cpp and okay, so I move on to this, right? So I compile it. Let's go. Okay, so I take in string, let's say Shane will ash ketchup. Okay, Shane will ash ketchup. So we got that right, and then print the concatenate string. Next, change the program to separate adjacent input strings by a space. So what we can do is I can put a little space here. There we go. Shane will ash ketchup. Shane will ash ketchup. Okay. Okay, then we move on. Okay, dealing with characters in a string. Often we need to deal with the individual characters in a string. We might want to check to see whether a string contains any white spaces, or to change the characters to lowercase, or to see whether a given character is present, and so on. Okay. One part of this kind of processing involves how we gain access to the characters themselves. Sometimes we need to process every character, other times we need to process only a specific. Okay, so one part of this kind of processing involves how we gain access to the characters themselves. Sometimes we need to process every character, other times we need to process only a specific character, or we can stop processing once some condition is met. It turns out that the best way to deal with these cases involves different language and library facilities. The other part of processing character is knowing and or changing the characteristics of a character. This part of job is handled by a set of library functions. Okay, these functions are defined in CC types. These functions are defined in CC types. The use of C++ versions of C libraries. In addition to the facilities defined specifically for C++, the C++ library incorporates the C library. Headers in C have names of the form name.h. The C++ version of these headers are named cname.h. They remove the .h suffix and precede the name with the letter C. The C indicates that the header is part of the C library. Hence, CC type has the same contents as C type dot H, but in a form that is appropriate for C++ programs. In particular, the names defined in the CNAME header are defined inside the std namespace, whereas those defined in the .h versions are not. Ordinarily, C++ programs should use the CNAME versions of the header and not the name.h versions. That way, names from the standard library are consistently found in the std namespace. Using the .h header puts the burden on the programmer to remember which library names are inherited from C and which are unique to C++. Okay, so processing every character using a range based for. If we want to do something to every character in a string, by far the best approach is to use a statement introduced by the new standard, the range for statement. This statement iterates through the element in a given sequence and performs some operation on each value in that sequence. The syntactic form is this. Okay. Where expression is an object of a type, that represents a sequence, and declaration defines the variable that we'll use to access the underlying elements in the sequence. Okay. On each iteration, the variable in declaration is initialized from the value of the next element in the expression. A string represents a sequence of characters, so we can use a string as the expression in a range for. As a simple example, we can use a range for to print each character from a string on its own line of output. Okay, so there we go. String, then we for out of C prints characters every char and str. The for loop associates the variable C with str. We define the loop control variable the same way we do any other variable. In this case, we use auto to let the compiler determine the type of C, which in this case will be char. Okay. On each iteration, the next character in str will be copied into C. On each iteration, the next character in str will be copied into C. Thus, we can read this loop as saying for every character C in the string str, we do something. Okay. The something in this case is to print the character followed by a we do something. As a somewhat more complicated example, we'll use a range for and the is_punct function to count the number of punctuation characters in a string. Okay, string. So we go declare type punch count, start the same type as s.size. Yeah. Count the number of punctuations. So we go auto s is_punct, then we increment the punctuation characters. See, and in the end we list out has 3 punctuations. So we get, there we go. Okay. Here we use declare type to declare. A counter. Its type is the type returned by calling the s.size, which is the string. Then scope operator, size underscore type. We use a range for to process each character in a string. Okay, we use a range for to process each character in the string. The time we check whether each character is punctuation. This time we check whether each character is punctuation. If so, we use the increment operator to add 1 to the counter, and then when the range for completes, we print the result. Okay, so this is a list of CC type functions. So is alnum if C is a letter or a digit. Okay, alpha, C is a letter. Control, C is a control character. Digit. Okay. C is graph. True if C is not a space but is printable. C is lowercase. C is a printable character. Example, that is space or a character that has a visible representation. Okay, punctuation is a space, white space, tab, vertical tab, return new line. Is uppercase is okay, hexadecimal digit. Okay, 2 lower, 2 upper converts. So okay. So we go using a range for using a range for to change the characters in a string. If we want to change the values of the characters in a string, we must define the loop variable as a reference type. Okay. Remember that a reference is just another name for the given object. When we use a reference as a control variable, that variable is bound to each element in the sequence in turn. Using the reference, we can change the character to which the reference is bound. Okay. Suppose that instead instead of counting punctuations, we wanted to convert a string to all uppercase letters. To do so, we can use a library toUpper function, which takes a character and returns the uppercase version of that character. To convert the whole string, we need to call toUpper on each character and put the result back into the character. So on each iteration, C refers to the next character in S. When we assign C, we are changing the underlying character in S. So when we execute this, we are changing the value of the character to which C is bound. When the loop completes, all the character in str will be uppercase, processing only some characters. Okay. A range for works well when you need to process every character. However, sometimes we need to access only a single character or to access characters until some condition is reached. We might want to capitalize only the first character or only the first word in the string. Okay. So there are two ways to access individual characters in string. What is the time here? 20. Okay. String, we can use a subscript or an iterator. Okay. Iterator. The subscript operator takes a string size type value that denotes the position of the character we want to access. The operator returns a reference. Okay, see, given character at that position. Subscript for string start at 0. If S is a string with at least 2 characters, then S0 is the first and S1 is the second, and the last character is in here. So size 2 minus 1 is 1. Okay. The values we use to subscript a string must be greater than or equal to 0 and less than size. Okay, the result of using an index outside of this range is undefined. By implication, so does the size include, let's say, less than size? Okay, because 0. Oh, right, obviously. By implication, subscripting, because the indexes start at 0 and size is actually the number of characters. By implication, subscripting an empty string is undefined. Okay. The value in the subscript is referred to as a subscript or an index. The index we supply. Okay. The value in the subscript is referred to as a subscript of or an index. The index we supply can be any expression that yields an integral value. Okay. However, if a string has a signed type, if our index has a signed type, its value will be converted to the unsigned type that string represents. Okay. The following example uses a subscript operator to print the first character in the string. Before accessing the character, we check that S is not empty. Anytime we use a subscript, we must ensure that there is a value at a given location. Okay. If S is empty, then S of 0 is undefined. So long as the string is not const, we can assign a new value to the character that the subscript operator returns. Okay. Then using a subscript for iteration toUpper S. As another example, we'll change the first word in S to all uppercase. Okay. Process characters in S until we run out of characters or we hit a white space. Okay. Index equals 0. Index is not size and index is not a space. So we is the first. Okay. So a for loop uses index to subscript s. We use tackle type to give index the appropriate type. We initialize index to 0 so that the first iteration will start on the first character in s. Then on each iteration we increment index to look at the next character in s, and the body of the loop we capitalize the current letter. Okay, the next part, the new part in the loop is the condition and the for. The condition uses the logical AND operator. This operator yields true if both operands are true and false otherwise. Then the important part about this operator is that we are guaranteed that it evaluates its right hand operands only if the left hand operand is true. Okay, we are guaranteed. See, this is important. In this case, we are guaranteed that we will not subscript s unless we know that the index is in range. Okay, not equal to. We can say is less than. And in this case, we are guaranteed that we will not subscript s unless we know that the index is in range. That is, s of index is executed only if index is not equal to. Because index is never incremented beyond the value of size, we know that the index will always be less than s of size. Okay. When caution subscripts are unchecked. Okay. When we use a subscript, we must ensure that the subscript is in range. That is, a subscript must be greater than or equal to 0 and less than size of the string. One way to simplify code that uses subscript is always use a variable of type this string size type as the subscript. Because that type is unsigned, we ensure that the subscript cannot be less than 0. When we use a size type value as subscript, we need to check only that a subscript is less than value returned by size. The library is not required to check the value of a subscript. The result of using an is undefined. Sorry. Using a subscript for random access. Okay. Using a subscript for random access. In the previous example, okay, is it recording right? Okay. In the previous examples, we advanced our subscript one position at a time to capitalize each character in sequence. We can also calculate a subscript and directly fetch the indicated character. Right? There is no need to access characters in sequence. As an example, let's assume we have a number between 0 and 50 and we want to generate the hexadecimal representation of that number. We can do so using a string that is initialized to hold 16 hexadecimal digits. Enter a series of numbers between. Okay, that's easy. So this will be ABC C05F. That's easy. Just concatenate it. Separate it by spaces until finished. Then we go size type n, C of n. Well, C of string size type n. Okay, well, and we increment n. We don't increment. Okay, if n. Oh. Oh. Right. Okay, that is clever. We take this as a subscript. While C of n, so we enter numbers, and then n is less than hex size dot digits, so we make sure that we are not going past 16 I mean to say. Hex digit, your number is this. Okay, so we start by initializing hex digit to hold the hexadecimal 0 to f. The string const. Okay, we made the string const because we do not want these values to change. Inside the loop, we use input subscript hex digit. The value of hex digit n is a char that appears at the position n in its hex digit. For example, If n is 15, then the result is f. If it's 12, c, and so on. We append the digits to result, which we print and read all the after reading all the input. Whenever we use a subscript, we should think about how we know that it is in the range. In this program, a subscript n is a string size type, which, as we know, is an unsigned type. As a result, we know that n is guaranteed to be greater than or equal to 0. Okay, so we have this, declare this. Okay, before we use n to subscript hex digits, we verify that it is less than the size of the hex digits. And then we move on to exercises, which I'll cover next time around. So for now,